Hello everyone. Today we are going to discuss Banker's algorithm. It is used for deadlock detection, and why the name is given as Banker's algorithm because it is used by the bank manager. How it is used by the bank manager? Because in a bank in a bank there are number of account holders who have already deposited some money in the bank. For example, an account holder P0 have already deposited 10,000 in his account. He has withdrawn some amount, for example 5,000 from his account, and he knows he have 5,000 in the bank. So when the P0 account holder wants to withdraw 5,000 from his account, whether a bank actually has that much amount for allowing that kind of withdrawal. What the bank manager will do, it will check what is the actual amount in the bank. If for example the actual amount in the bank is 3,000, so how the process P0 is allowed to withdraw 5,000? That is not possible. So that is the same scenario in Banker's algorithm, in which we are going to have the data structure as processes P0 to, for example, P4, matrix, allocation matrix, in which we are going to have the instances of the resources, for example A, B, C. For example, the resource is printer. A will be the laser printer, B will be the dot matrix printer, C can be the inkjet printer. So these are the different instances of printer resource. Then we are going to have mass matrix, again the different instances of that resource and the available matrix. So if the resources are already allocated but actual need by the resources is given in the max matrix, so with the number of resources available, whether the need can be satisfied by that process or not. So for that, what we are going to do, first of all we have to calculate the need matrix. What is the formula of the need matrix is that we are going to have the max minus allocation matrix. So this is max minus allocation. Okay, so the need will be max minus allocation. For example 7, 5, 3 will, from that we are going to detect 0, 1, 0. So what will be the answer? The answer will be from 7, if we are going to detect 0, it will be 7. From 5 we are going to detect 1, it will be 4. From 3 we are going to detect 0, it will be 3. So that is the amount of the need matrix of process P0. Now similarly what we are going to do, we are going to find the need matrix for the remaining processes. For example, the need of the process P1 will be 322 minus 200, that will be 122. So similarly we have to calculate for the remaining processes. Now we are going to discuss about the safety algorithm. What is in the safety algorithm is that we are going to check whether the need of the processes are less than equal to available, which is similar to our previous video in which we had discussed resource allocation graph. So the need of the processor has to be less than equal to available, then only that resource will be granted to the particular processor who is needing it. So here we are going to consider available will be equal to work matrix finish of I, that is whether all the process has completed that task or not. So we are going to find an I such that the finish that process not completed execution and the need of that process is less than equal to what, that if that particular I is fulfilling this condition, so that particular I, for example 0, process P0 has not completed stars and its need of process P0 is less than equal to 1 matrix, work matrix. So at that time what we are going to do, that process will be added into the safe state. For example, that P0 will be added into the safe state. Then we are going to find the second I. Before that, what we are going to do, the P0 is going to complete its execution, and whatever resources were allocated to process P0 will be given back to the available matrix, that is the work matrix, and we are going to make finish a process 0 as true because process P0 has completed its task. After that we will go back to the step 2 only, in which again we are going to find any process who has not completed its task, whose need is less than equal to work. If such process is found, then what we are going to add that process into the safe sequence. For example, this time instead of P1, P2 has satisfied these two conditions, so P2 will be added into the safe sequence, is going to return its allocated resources back to the work, and the finish of that process P2 will maybe mark as true. Again we will go back to the step 2. Again we are going to find an I till all the processes have completed their execution, and at the end what we are going to find, we are going to find the safe sequence in these two brackets. For example, P0, P2, for example P. Suppose the question is we have 5 processes. What we are going to do, first question, that what will be the need matrix, if whether the system is in the safe state, if yes, what will be the safe sequence. So today we are going to discuss only 2 questions. Remaining questions will be done in the next video. Okay, so what with the need matrix, we had already discussed. The need matrix is that by using the formula max minus allocation is 753. From 753 we are going to subtract 0 1 0, so answer will be 743. Similarly for P1, the mass matrix of P1 is 3 2 2. From 3 to 2 we are going to subtract 2 0 0. So what will be the answer? From 3 if we are going to subtract 2 will be 1. From 2 we are going to subtract 0 will be 2. From 2 we subtract 0 will be 2. So similarly we had found the need matrices, the need elements of all the processes. Now the question number 2 is whether the system is in the safe state or not. If yes, what will be the safe sequence? So we will start. We will initialize work. We will initialize work to the available matrix. So what was the available matrix that we are going to initialize? So what was the available matrix is 3 3 2 will be assigned to work. So this is your work matrix, and initially finish of I will be false, so we had marked finish of I false for each and every process. Now the next step we have to find an I. We will start I will be 0. We will search whether the matrix of process P0 need is less than equal to work. So here we had found that the need of process P0 743 is not less than equal to work matrix 7. Whether the 7 is less than equal to 3, no. Whether the 4 is less than equal to 3, no. The 3 is less than equal to 2, no. So that means we are going to not consider process P0. Then we are going to increment I will be 1, and again we are going to check whether these two conditions for process P1 is satisfied or not. So here for I, the need of I is now less than equal to work. So the P1 will be taken into the safe sequence. Okay, then whatever resources were allocated by P1 will be added to work, and then we are going to mark the finish of process P1 as true. Okay, so because of that, the work, that is the process P1 was actually having 200, that will given back to or added to 332, so output will be 532, will be the actual work matrix. Okay, then again we will find the next I such that finish of I is false and the need of that I is less than equal to work. So we have jumped to or incremented I by 1. So we got that I is equal to 2. The need of that matrix is not than equal to work matrix. Then we have incremented I by 1. So the process P3 need is less than equal to work. So that will be added into the safe state. Then it will going to return allocated matrix is P3 will be return is allocated matrix back to the work. Because of that, work will be 743. Finish of that we have to mark as true. Then again increment I by 1. Check the need with the work. Here also the condition is satisfied. The P4 will be added into the safe state, and the resources allocated to P4 will be given back to the work matrix. Finish of P4 will be marked as true. Now increment I by 1. So here in this case, after incrementing I by 1 will be 5, but we don't have any process, we will go back to 0. Now check whether process P0 need is less than equal to work. Yes, this condition is satisfied, so P0 will be added into the safe sequence. Then P0 will release all the resources. Now check in the we have to check in the array of false array which one is remaining false. So here process P2 is remaining false, that is we are not going to finish our execution till all the processes have completed their execution. That is the finish of all the process has to be true. That means now we will continue our execution again such an I. So now this time after I is 0, process 1 has already completed its execution, so we have to jump to process P2. Check the condition, the need is less than equal to work. Then what we will do the addition and will mark finish of I as true. After that, what will happen, we are going to check in the false matrix. We will check in the false matrix whether all the processes have completed their execution to the end to terminate our safety algorithm, and at the end what we are getting the safe sequence. So hope you people have understood the concept of safety algorithm, which is the one part of Banker's algorithm. In the next video we will discuss resource allocation algorithm. Thank you.